I see Godfrey's also here. So, Pedro, take it over.
Can you hear me?
Yes, we can hear you now.
All right. Well, thank you, Simeon. Hi, everyone. Nice meeting you. Let me start by sharing my presentation. Give me a second. Too many windows open. Can you see my screen?
Yes, we can.
Great. Well, my name is Pedro Barreto from Crosslake Technologies. For those of you who don't know me, I've been working with Moduloop for the past 3 years. I've been mostly focusing on the performance side of things and the architecture side of things. I'm also participating in the design authority. And for the past year and a half, 2 years, I've been working with a lot of the community members on two big important aspects of Moduloop's future. One is the reference architecture that we have now produced and documented. And the second one, or the last one, is the vNext implementation, which is the next iteration for Moduloop that embodies all of the principles and all of the design principles that we have defined for during the reference architecture sessions and design effort. So with that, let me get started with the presentation. Obviously, I'm representing the whole team. It's just me today presenting, but this is a big team effort, so don't confuse me with the rest of the team. So the agenda for today's presentation is this one. We'll start with a quick vNext build status update. We'll then go into a bit of the details of the actual implementation. We'll do a demo this time, and we'll wrap up with the usual wrap-up slides. So in terms of build status, we haven't, we've been working towards the alpha version of the vNext update. And I'll explain what alpha version means for us. And for the past 2 PIs we've been developing, we don't have a lot of resources, but we've been focusing on getting the cross-cutting concerns and the participants and accounts and balances parts of the vNext functionality working in alpha version. So what we think, or what we consider an alpha version, is essentially minimum use cases with no concerns for being able to run in production. So we don't have production execution concerns. Once we have those components done in alpha version, we will proceed to a beta version. That beta version will essentially be the complete use cases of each of the bounded contexts of each of the parts that we are developing, still with no big focus on making it production ready. So at the end of the presentation, I'll show exactly which components we have completed in alpha version, which components we are working still on them, and which components are outstanding, are pending, because we need to start developing them. So the quick update, the quick status update for today is we have all of the cross-cutting concerns, well, not all, pretty much 90% of them in alpha version, which means that they execute the most important functions, and this is a really good news. And in the past month or so, we've been producing the participants and accounts and balances alpha versions as well. So today we have something that starts to resemble a system. It's not just technicalities. Okay, so and now we'll go through some of the implementation details. We realized that so far we haven't shown anything that we have built. Today we're going to discuss not so much what the reference architecture tells us to do, but what we have in code. This is the overview of what we have now. And by the way, this is not a formal diagram. This is just to represent in the screen what we have built today in different layers. The layers don't necessarily mean boundaries of communication between the parts. So what we have on top is the external systems, like the DFSPs that are going to be connecting to Moduloop, and the operator UI that's also going to be connecting. In the middle, in Moduloop Blue, what we have is the participants bounded context and the accounts and balances bounded context. So these are the functional blocks that already work. In yellow, in the almost bottom, or the next bottom layer, we have all of the cross-cutting concerns. All of those things that you're seeing here are implemented. The majority or the most important use cases for these cross-cutting concerns are already working. Obviously not production ready. This is just the initial foundation. So we have platform configuration, security, and security we're splitting in two parts: authorization and authentication, and this is an important distinction. We have auditing, logging, and scheduling. And on the bottom part, what you see is either data stores or external systems that we integrate with. So again, don't take this as a formal diagram. This is not how the architecture actually works. This is just for ease of representation. So next, I'll explain a bit of what is the philosophy of development in terms of what are the code deliverables that that we're targeting as we write code. So first, we are separating public types from implementation. This is a very important aspect because you probably all know that we're using TypeScript. TypeScript is the official language for everything that is new. So we are using TypeScript. With that means strong types for objects and for the code that we write. It is really important that we are able to provide public typing for the multiple parts of the system that we use. What this means is that I'm able to incorporate a certain interface in my application, whatever the application that I'm building, by simply depending on a public types library. And this is nuanced, but it is an important distinction. I'm not importing, or I don't need to depend on a client. I don't need to depend on an actual implementation. I can simply depend on public types library. That public types library is going to be stable because it only includes the type definition. It's not going to be including any of the implementation that is associated. So the objective here is that we have a public types library for things that define, for example, what is an audit entry? What is the structure of the audit entry? What is the structure of an audit client? By having those types, we are able to have valuable code, for example, like the participants, that depends exclusively on the public types library and not on any specific implementation of those public types. This is really important because with this, we can achieve dependency injection and inversion of control objectives. And obviously, those two strategies severely reduce the dependencies, which means that if we later have to refactor some of the public type implementations that we have, we don't really have to break all of the code that is using our dependencies. So essentially what I'm saying is, if I need to change the way auditing works or the way the audit client works, I just need to change the actual implementation for the audit. I don't have to change the public types, which means I'm not going to have to change or impact negatively the participants code that uses auditing, the accounts and balances, and every other code that is using exclusively the public types dependency. So this is, I spoke a lot about this because this is really important. This is one of the principles in our philosophy. We don't want to design a system that is overly complex and that is brittle, in the sense that if we change some piece of code somewhere, it has a cascading effect because it breaks all of other components that are depending on it. So yes, we do provide libraries so that other parts of the system, other developers can have the benefit of speeding up the development because a lot of the implementations have been done, but we want to keep those implementations from those types separate as much as possible so that we don't have those dependencies and those negative effects of breaking changes. So that's the first point. The second one is we are providing as much as possible client libraries. So what we mean by this is that obviously we're all using TypeScript. So if you need to use, for example, the accounts and balances to create an account or to create a journal entry, there's going to be a client for you. So as a client of that functionality, you just depend on the client library, you instantiate the client library, and you start using a very high level and very easy to use and well-documented client library that allows you to create accounts and to create journal entries. The same philosophy is being used for pretty much everything that we are using. Every backend component that provides functionality to the rest of the platform, to the rest of the applications that make up the vNext platform, provide a client library, not just public types. And the last point about our design philosophy, which is I know it's a contentious point, not everyone agrees with monorepos, it's one of those big discussions. We opted, and these principles, obviously, it's important to mention that they come from the previous implementation that we had with the performance POC and some of the experience that we had. What we are now using is a monorepo per bounded context. So what we're doing is, and Simeon was mentioning the bounded context before. A bounded context, for those of you who are not familiar with, is a block of cohesive functionality in the system. So if you look at all of the module loop, you will see that there's participants, there's accounts and balances, there's quotes, there's transfers, there's management aspects, there's interoperability, APIs, all of those big chunks of functionality, according to the design that we did, the design effort that we did with the reference architecture, those are bounded contexts. So what we have in terms of code structure is we have a mono repository, a single repository for each bounded context. What it means is that we are able to pack in a single repository the client libraries, the public types, and the multiple services that make up a bounded context. So this is an important point to mention. Okay, so now going to the actual stuff that we've been building and starting with the cross-cutting concerns. We have the platform configuration bounded context, and essentially this is a mechanism that allows any application of the platform to define its own schemas, and a schema can have parameters, feature flags, and secrets, bootstrap those schemas to that central component that is the platform configuration services, and essentially telling the central system, I am an application, I need to function some parameters, some feature flags, and some secrets. Now, those will be versioned, and those will be changeable. What it means is that once that application schema has been bootstrapped, an operator can go to a central management console and change the parameters of a certain application, change feature flags, and change secrets. This is really important because then we will have things like automatic reload of parameters, and we don't have to redeploy any applications so that they can reuse different parameters. So this is really important. An important point to mention is also that these parameters, feature flags, and secrets, they are not necessarily technical parameters. We're not talking about the URL to a database or some username or that sort of thing. We're talking about parameters that change the way the application works. For example, which settlement model we are using, that's going to be a parameter. If make a checker is mandatory or it's not mandatory, which feature flags are enabled? Are we using the certain new code that we want to experiment in a certain platform? And for that, we use a feature flag. So the point is, these are not technicalities. These are parameters that applications can now use and basically delegate to a central management system so that they can, so that operators can configure the applications without touching the applications themselves and without redeploying the application. So this is an important aspect. And that little box that you see on the bottom right side, this is the amount of components for each of these bounded contexts. In this case, I'm going to read through this one and skip the next one. But in this one, the platform configuration is made up of one REST backend service, one client library, and one public types library. So going on to the security bounded context. Security is made up, according to the model that we have, to the reference architecture design, is made up of authentication, which is the ability to log in users and applications. Authorization, which is the ability to define and to make decisions about who and which users and which applications can do what in the system, which activities in the system. Cryptographic functions, and also which include key management store. So those three big chunks of functionality are inside the security bounded context. As you can imagine, this is one of the most important bounded contexts that we have from the cross-cutting concerns, bounded context, and it packs a lot. in today's implementation of module loop, we don't have security. We don't have platform configuration either, but security is a very important aspect because the way we are building vNext is to integrate from the ground up all of these concepts, which means that we don't have to add on top of module loop security for the next version. It will come as a first-class citizen. So we have those three big areas. Going to the authorization, we have native role-based authorization, an explicit one. What this means is that there's going to be roles, there's going to be application privileges, and unless an operator composes roles with certain privileges, roles don't have automatically any privileges to start with. So essentially what we're saying is this is almost like a zero trust security model where unless someone added privileges to a role, to compose a role, and then associated a role to a certain user or to a certain application, no one has access in the system. So it's a zero trust system by default. And then what we have is those per application privileges that I was mentioning. What this means is that it's a bit like the logic of the platform configuration. Each application will define what are the privileges that the application needs to operate. Essentially, every time that an application code needs to ask the question, can a certain user or a certain application that's calling me do this operation, we're going to create a privilege. The privilege can be execute a transfer, approve a participant, create a participant, create a quote, rename some object. So this is the unit or the atomic authorization principle. Essentially, can someone do an activity? That activity is going to be a privilege. Each application will, as they start, like the platform configuration, they will have a schema that details all of the privileges that a certain application needs. When a new version of the application is published, those privileges will be bootstrapped to the security bounded context. At this moment, the security bounded context will have now the knowledge about all of the privileges from each of the applications. And at this moment, again, some operator can compose the roles with the different privileges that make up the system. So this is, it's the standard model of privileges belonging to a role and then role belonging to a user or a group of users or an application. We're just putting this from the ground up into vNext in a way that is distributed. It is distributed because each application publishes the privileges, but the security bounded context in the central services, they are not aware of the application. So again, we're trying to decouple this as much as possible so that the different parts of the system can be resilient and not depend on each other and not call each other. There's a pluggable IAM, identity and access model, mechanism. What this means is that when we are authenticating, we're actually authenticating against the security service, the authentication service in the vNext platform. And that in itself is going to call a pluggable module. So essentially what happens is that we have a mechanism of creating multiple connectors, let's call them as a connector, it's an adapter, to endpoint authentication mechanisms. This could be a local file-based authentication, a local database, an Active Directory, or some cloud IAM for cloud-based IAM, for example. So essentially what we're allowing to is we're not going to be implementing every possible connection to every possible IAM. So we are designing this in a way that anyone can bring new code to create a new adapter to connect to whatever authentication mechanism they have. In essence, what this means is that if you're implementing module loop and you have an Active Directory where you would like your users to come from and your roles to come from, it's going to be really easy to do this. Essentially, you just create a connector for that, assuming one won't exist by the time you try to implement, and then you are just going to need to map the roles to the roles that exist in your IAM, either group-based roles or actual roles from Active Directory, for example. So the same will apply for cryptographic functions and key management stores. And hardware-based cryptographic mechanisms, all of those functionalities are being today abstracted via a mechanism that allows us to create a new connector, a new adapter to some other mechanism of providing this functionality. Effectively, what we have is we have this first internal layer of security in the platform, which is platform specific. And that's going to be talking to the internal applications of Moduloop. And then we have that layer on the outside that allows us to connect the security in a very secure manner to any security considerations or providers on the outside. Again, this is all centrally managed. There's APIs and to manage the security aspects. Logging. We have a logging and we have an auditing mechanism. I'm going to quickly go through the differences between logging and auditing because it's not unusual to interchange those two. Logging, in the simplest terms, is for developers. So essentially, as a developer, I want to know what the application is doing. Auditing is for auditors, is for business. It's not for developers. Auditing is about what happened in the system of relevance that makes the system state be what it is today. So if I'm an auditor, I want to know why a certain number exists, why a certain value exists, why a certain state of the system exists, and how did it get to there. So with that difference explained, the logging bounded context that we have is again made by a central service, a REST service, client library, and a public types library. And what we're delivering is flexible and fast logging. This is well, purely because I only had two real important points at this. It is developer friendly. Again, it's just a quick library that's really easy to use. It's pluggable, which means that we don't have to use the same logging implementation all over. We don't have to use the full-blown distributed logging mechanism. We can have a console logging as we are developing. It's really flexible in the sense that we can develop quite nicely and then have the same code that we are calling the log. We use exactly the same code and we are suddenly logging against the production mechanism. So this is really important. And again, on the central storage system, we are able to replace the databases. Today we are using Elasticsearch. We can use whatever we want because there's an adapter layer again at the REST service. So this is applicable to pretty much everything that we have. On the auditing, I'm going to spend a bit of time talking about the auditing. This is a really important aspect. I recall the discussions initially in a year, probably more than a year ago with Miller about the importance of making sure that auditing is read-only and we can prove that a certain action was made, and this is tamper proof. So what we have is a two-layer cryptographic signature mechanism. Essentially, we have the client that will have its own private certificate, and we have the service that has its own certificate as well. What happens when an application using the client, the audit client, audits an entry, is that in that first moment, that client is going to it's going to create a cryptographic signature of the audit entry. And it's going to be sending the audit entry to the service along with that signature and the ID of the certificate that was used to sign. Once that package gets to the back end of the auditing mechanism is going to open the package, validate, and it's going to envelope again the package that it received from the client. It's going to create another signature, which is this time the server signature. It's going to then store the full package, which includes the original auditing entry. It includes the original client signature from the application. It then includes the signature from the backend, and all of this is stored in Elasticsearch. So what this allows us is to have the ability to, by providing the public keys or the public certificates for both the application that is logging and the auditing. Sorry, I keep saying logging, but I mean auditing. So with the public certificate of the auditing client, of the auditing application, and the public certificate of the auditing service, we can verify that the audit entry was tampered or not. So this is an important mechanism that we have, and we have achieved this. Associating this with a read-only storage mechanism will provide the business goals that we have discussed since the beginning for auditing. So again, we have the same pluggable central storage. This is transversal to pretty much everything that we've been implementing. All of the infrastructure aspects can be replaced. So that's it for auditing. Scheduling BC, so scheduling bounded context. What is this? This is essentially it's a platform-wide and scalable cron tab. During our discussions, reference architecture discussions, we had lots of points where we were discussing how can I do something that happens 5 minutes from now? How can I make sure that my system generates a report every day? All of those parts of the systems, essentially what they need is they need cron tab mechanisms. They need mechanism that is time bound to execute some tasks. So what we designed during the reference architecture was a scheduling bounded context. Essentially what this allows us is allows an application to register for either a recurring or a one-shot reminder that says, hey, in 5 minutes time, send me an event, or in 5 minutes time, call this URL, which is probably belonging to my application, or every day at 2 o'clock, send me this event or call me at this HTTP address. So this is very simple. The point that we're trying to achieve is that by having this, we are now simplifying everything that needs to be scheduled throughout the rest of the application. And we have this benefit of having centrally everything that we can schedule. We have visibility. Okay, going to the functional bounded context. Today, we have implemented the alpha versions for those two, participants and account balances. For the participants, what we have is fully separate and testable domain logic. This applies to pretty much all of the bounded context that we have developed so far, even the cross-cutting concerns, but especially important to the functional bounded context. The point is, we have domain logic that, in essence, is completely separated from any infrastructure concern. So imagine participants as having, well, not imagine, participants have business rules. Those business rules today are implemented in what we are calling a domain logic packet. And this is very simple code that executes and enforces the business rules, nothing else. It has no concern for infrastructure. Essentially, I'm not going to the details right now, but by using inversion of control and dependency injection, what we are producing is a domain logic package that expects to receive upon construction or instantiating the infrastructure components. And inside that domain logic, the only thing that we do is test that a participant has a proper name, that the valid rules apply, that, for example, in the accounts and balances, there's balance. So effectively, we have the valuable code of our application, testable and separated. So we can change business logic without the fear of touching infrastructure code, and vice versa, which is probably more important. We can change infrastructure. We can implement different infrastructure code without touching the rules that make our platform work as it should. So again, this is the first candidate for the role-based authentication authorization that I was mentioning, participants. And this is something that we will see in the demo. And we have native make a checker embedded. Going to the accounts and balances, again, we have a fully separate and testable domain logic. We have a black box approach to the ledger. The way we designed this according to the reference architecture, accounts and balances is completely separated from the rest of the system. It's essentially a ledger that is driven from the outside. It has no idea that it belongs to Module. It has no idea about what a transfer is or what a settlement is. Essentially, from the outside, participants, transfers, and settlements will create accounts and then create journal entries, and that's it. The accounts and balances will behave as a very simple ledger This is multiple benefits. The first one is that we are uncomplicating everything, and it becomes really simple to test the domain logic. We can replace the accounts and balances. Later on, the participants, the transfers and the accounts and balances are probably a candidate to replace with Tiger Beetle. There's going to be more news on that later. So for now, the implementation that we have is really simple. Accounts and balances is also controlled from the outside. So essentially, participants, settlements, and transfers control and direct what the accounts and balances need to do. And the domain logic obviously pertains to the accounts and balances. This is also going to be the first one to include a gRPC binary interface. This is going to be our first experiment by having an ultra fast and light, very light in terms of performance and network binary interface. This is one of the conclusions that Miguel and I came to when we completed the performance POC, which was we will probably unlock a lot more performance if we start using very fast interfaces that don't use verbose JSON text going through the network. So this is going to be the first one. Okay, I'm going to stop sharing now, and this is time to do a demo. Let me just change to share the demo. Apologies for this. There's a lot of windows open. All right. Can you see my screen?
Yes.
Yep.
So this is this admin UI is not just for the demo. What you're actually seeing is the humble beginning of a modulo next version administrative operator portal. So we didn't build this just to show off that we have stuff. This is, again, much like the cross-cutting concerns like security, platform configuration, all of those things that we're embedding from the ground up in the vNext platform. A UI, a management UI that is secure is also included. So I'm going to start by logging in, and I'm going to use my super secure password. And this is, I'm trying to not show the stuff that I know it's broken. So give me so the first thing that I'm going to show you is this is already using the authentication and the authorization. So what you're seeing now is this is my page as a user. I'm the administrator. I'm logged in as the administrator user. And what I'm seeing is my profile page, a very crude one, but this is my profile page. And what we can see in this page is that I was granted, or I was given, I belong to the platform admin role. And if I click here, I'm going to see the object that makes up the role. This is not very interesting, but the role in this case has privileges associated to it. And in this list of privileges, what you can see is that this platform admin role includes the ability or the privilege to approve a transfer. And this is from the platform admin role. Obviously, I only have one role, so everything is going to come from that role. But if I had multiple roles, I would be able to see which privileges came from which roles. Then I have a very short description about what this privilege means in terms of the application and the owner application. So I can see that, for example, this one, the view participant privilege, is from the participant's bounded context, from the participant service application, and in its version 003. So essentially, I have the ability of seeing what I can do in the system. And I can do this in the system, application by application. We don't have yet the management aspect of this. So there's no buttons yet to create a new role or to associate privileges with roles. We can do that already by using a REST API. So that exists already. It's just not in the UI. So if we scroll down, what we see is this is the token. So we're using JWTs, so JSON Web Tokens, for and when we authenticate against the system, we're going to get back this well, actually what we get back is this long string of characters. And when these are decoded, what we get is this. There's an important mention to make with access tokens. The way they work, this is cryptographically signed. There's a part of this, I think it's the end, there's a part of this which is the signature, which means that not only we cannot change this without breaking the cryptographic signature, we cannot change the content or the type, the payload that comes in the token without breaking the signature. The way we have this implemented is the typical standard way, which is the authentication mechanism provides an endpoint that allows anyone from the outside to consult its public certificates, the public part of the certificate, which means that my UI application can log in, receive a token, and then look at the token and look at the public certificate of the authentication service and say, was this signed by that public token? And thus realizing or confirming that this is a valid token for this application. One thing that you will see is that this token contains the roles. So what this means is that every time that my application receives a call, whatever the application is, a UI or a call to a backend REST API, that receiver of the call will have this token, which means that I do now know who's calling me and what are the roles that that user belongs to. So I don't have to do an extra call. This is an important aspect of the distributed mechanisms that we are implementing. So essentially, this is what you see. This is all of the information that we pass in that token. And this token allows us to, for example, know that I'm the user admin and I have this role, and then this role means certain things. So I'm going to go now to the platform configuration, and this is just to show what are the registered applications that we have who have submitted a schema for its configuration. We have obviously a test. There's no demo without a testing, and we have a TypeScript template. This is another test. And what we can see is that we have two applications in here who have submitted their platform configuration schemas, and there were changes made to those schemas or to the values of those schemas. And in this case, those two, both of them are in their second iteration. Again, it's important to notice that these components are versionable, so we can actually have evolved the applications, and obviously evolving applications have different parameters and different configurations. And every time that we change centrally the values of a certain configuration, what this means is that there's going to be an iteration on that configuration change. At this moment, there's going to be a trigger to the application so that the application knows that a certain value or a certain parameter was changed. Going on to the list of parameters, this is the example parameters. We have in the first column, there's the definition of which bounded context and application and version the parameter belongs to. There's the name of the parameter, the type. They can be booleans, strings, integers, and float numbers. Later on, we will have a list so that we can choose between multiple options. Today, we don't have that yet. Each parameter will have, as provided by the schema that the application codes and defines, they have a default value, and then we have the current value. That's the one that is managed through the system. There's also a description so that we can have a nice UI that shows what the operator is changing. We have the same for feature flags and the same for secrets. Secrets are a special part in here because the secrets will come from a different secret management store. They will not be stored in the same place. So this is the participants, the configurations. And I'm now going to show the participants mechanism. The objective of this participants demo is to show the maker checker and the role-based authentication, authorization. So I'm going to create a participant. I'm going to create demo participant 1. I'm going to give it a very big and informative description. And I have my demo participant. So I have 2 participants now. In order to show this truly, I have to log out, and I'm going to log in with my operator level 1 user. So I'm going to use two different users because they will have different permissions. So if you see here, I'm the operator level 1, and I have the ability to view participants, create participants, disable, manage the endpoints, manage the accounts, but I don't have the ability to approve a participant or to enable a participant. And this is an important aspect. So I'm going to click the approve, and obviously I cannot approve this participant. I'm not authorized to do that. I will try to approve this one. Again, I'm not authorized. Because I have this information in the token, I could be smart enough as to not show the approve button in the UI. This would be the easiest way, or at least to gray it out, so that we make out a very good user experience. I left it like this so that we can test it. So what we can do is we can create a participant. So let's call the op1 participant. I have created this op1 participant. This was created by me, so I'm going to try to approve it. I cannot, because I don't have the ability to approve participants. Okay, so let's move to the next level of the demo. I'm now going to log in with an operator level 2. Let's see what the operator level 2 has in terms of roles. It has the level 2 operator role, obviously, and this role allows everything that the previous role allowed, plus the approval of a participant. And this is an important aspect for our demo. So I'm going to go here in the participants, and I can see that none of these participants is active, which means they haven't been approved yet. And I can see who created the participant. So I'm going to try to approve this one, and I was able to approve it. So the new participant, it was not created by me, was created by operator level 1. Remember, I'm level 2, and that means I was able to approve it. So this is approved. If I want to approve this demo participant that was created by admin, I will probably also be able to do it. So I'm going to be able to approve it because it was not created by me, and I do have the ability, I have the privilege to approve participants. Now let's check something. I'm going to create the op2 participant to see something. If I try to approve the op2 participant, I'm going to get an error. And this error is I cannot approve participant because that's the maker checker violation. So what this means is that my business logic, and again, this is something that is in the code, in the business logic. It's not, there's no infrastructure code, complex code whatsoever. What we're saying is we have a few lines of code that very clearly say the user cannot be the same. So there's a maker checker violation because I cannot approve my own participant, the participants that I created, even if I have the ability and I have the privilege to approve participants. So this concludes the demo. Let me just now show you. I'm going to stop sharing this and I'm going to share what happened in the auditing side of things. Let me try to. Can you see my screen? You're supposed to see a Kibana interface. So now what I'm showing is, let me refresh this. So on one side, in here, we're seeing the logs. I hope this is readable. The point is not to see the details, but what you're seeing here is the logs of the application. So there's the bounded context, there's the application name and the application version and the component for the cases where we have a component, and the message. And what we're seeing here is all of the activity that has been happening in the multiple applications that I have running here in my computer. And I have 7 or 8 applications, the cross-cutting concerns plus counts and balances plus the participants. So all of those things are registered as per normal logging. This is not very special. Today we have very good logging already. So this is now the auditing mechanism. And this is the one where I'm going to be spending a bit of time. So in here, you can see the same set of properties, the source bounded context, the application, and the version name. We now can see the action type. So this is the action that I'm auditing against. A participant was approved. Was the action successful? It wasn't. In this case, it wasn't. That was one of the cases where I was trying to approve my own participant and it was rejected. And then if I see the rest of the data, and this is a lot of data, so I really hope that this is visible, or at least it provides an idea. So we have an auditing service signature. This is that signature that is produced at the end in the service before storing in Elasticsearch the auditing entry. So the whole auditing entry that you're seeing was signed. This is the signature. I can use this signature and I can use this JSON document to verify if this JSON document was tampered with. And I can also verify who signed it, if it was the proper certificate, in this case, the auditing service certificate. I can see the caller network address, the sources. There's plenty of detail for those interested in the auditing. And here we have the source signature. So this is the signature of the initial entry according to the view of the client library. So this is the application initially that signed the entry that was later submitted to the service, signed again, and then stored in this Elasticsearch database. So the point is, these cryptographic signatures allow us to verify that none of this was tampered, that all of them were issued by the correct applications with the correct certificates. So this is what I'd like to show in here. And I will now go to my last bit of presentation where I'm going to share the separation of our code. Second. I hope you can see the screen. So this is just code, not very interesting for a lot of people. I mean, it's really interesting. And what we can see is, first we can see the monorepo structure. And this is the important bit. We have one repository for the accounts and balances bounded context. That's just one. And that includes several modules. One module in this case is the client. So this is the client that the participants uses when it wants to create an account or create a journal entry in the accounts and balances service. We have a service, an application service. In this case, this application service is a web server. So this is an HTTP REST-based application. We could have more applications. In the future, we will have a gRPC application that will equally serve the same functionality. And then what we have is, and this was something very important that I was mentioning before, we have the domain. This domain is made up of very simple code. So in this domain, you can see the aggregate. I'm not going to go through the code, that's not the point, but the aggregate has no concern about infrastructure mechanisms at all. So if you look at the constructor, you will get an interface of an implementation for a logger, a repository, and multiple other components, but none of them know about the details of the infrastructure itself. So this is a very powerful and an important concept, because what it allows us to do is to have multiple applications serving the same domain. So what it means, if I want to have a gRPC application that serves the accounts and balances functionality, I can do that. If I want to use REST, I can do that. If I want to use a local .NET, a local service, I can do that, because I can just reuse the domain. I call the domain instead of either including the code of the domain or embedding it. So this is an important aspect. All right, we're near the end. I'm going to go to the presentation. Apologies for this. I'm going to go to there. Let me share the screen again with the presentation. Okay, so that's it. We've done the demo. So this is the detailed list that I was mentioning before. This is the cross-cutting concerns list of components. As you can see, the alpha version's done doesn't mean that it's completely done and ready for production. Again, this is not even beta, this is alpha version, which means only the most important use cases. And what you're seeing in green is that we have the vast majority of the cross-cutting concerns implemented. So these are working. You saw pretty much all of them during my demo. We don't have time to show all of the details, but all of these components that are listed in green were working during that demo that I just did. So this is the cross-cutting concern build status. This is the functional status. So what we have is we have the participants bounded context service and the type sleeve, and we have the accounts and balances client and the service and the application. What we're missing is a lot. Obviously, we're missing transfers, quotes, account lookup, the interfaces, the FSOP, ISO, settlements, notifications. Settlements is twice. I hope we don't have to implement settlements twice, or at least that Michael can help us. So again, I don't want this to transmit the idea that we're done. We're not. We're just delivering the alpha version. As soon as we can, we're going to go to the beta version, and that's when we will have a more complete platform to show for. Okay, so in terms of resources and progress, during this last PI, the development accelerated really by a lot. And this is not because we had a lot more resources. This is mostly because a lot of that initial plumbing is done already. So last PI, we had an additional developer. It's Gonçalo Garcia. And obviously this contributed to the acceleration. The fact is that we're at the stage now where that initial plumbing is done. So we're not refactoring systematically. What we have is the cross-cutting concerns stabilizing, which means that we can, with confidence, start building the functional components, the participants, the accounts and balances, and all of that with a bit more speed and without going back so many times. So the good news is that for this new PI, for PI 19, we will have more time from Gonçalo, and we will have a new senior developer that will join. So we hope to keep on accelerating the pace at which we deliver vNext. And as always, we still need help. There's plenty to do. So if you have some time on your hands and you would like to be involved in developing the future version of Moduloop, please reach out and we'll make sure you have something to do. So the final thanks, the obvious one, I'd like to thank Gonçalo Garcia, Jason Brewer. These two guys have been participating in the development. Small team, very focused team, really important. Michael Wagoner, who's been working on the reference architecture documentation and doing a great job. And that's it. I would like to thank this team. Obviously, there's a lot of people that we need to thank for the reference architecture work that we did in previous years. Pretty much everyone in the community participated somehow. So I'd like to thank all of those folks. And that's it. So I think I hope we have some time for questions, because I know Godfrey has his presentation.
I think let's pass it to Godfrey in the interest of time, Pedro. But if there are any questions, it would be great to put them in the chat or in Slack.
Okay. Thanks everyone.
Okay. Thanks, Pedro. Thanks, Simeon. Just to align on the time, Simeon, how much time do I have? I don't want to overstep.
I'll give you 10 minutes and then I'll shift the break a little bit.
10 minutes is fine. I'll align to it. Okay. I'll just quickly bring my share. Okay. Is it coming up?
I don't see it yet.
Okay. I'll fix it quickly.
There we go. Can see it now.
Okay. Thank you. And hi everyone, and thanks again to have you again as part of this initiative. And yeah, it has been a very great journey to where we started and where we are. And very specific to the code quality and security workstream, we had a lot of busy kind of like PI in the past, and now we're actually kind of like close to that maturity stage wherein we're not being adding a lot of more new things. So for this PI, we really didn't have much to really contribute to the core, precisely because there's a lot of work that is happening that Pedro has reflected as part of the vNext. So, and also on the infrastructure as code, there's a lot of incorporation of security elements as part of the infrastructure as code. So we don't want to coexist too many projects or too many matters that really solve the same problem. But after those, we'll actually have to go back to the drawing board and see where more gaps are that could actually be addressed as kind of like a standalone non-functional aspects of this architecture. So for this period, it was really kind of like a snapshot of the OSS elements that we're leveraging, just to make sure that we are in grasp of all the supply chain possible issues that might arise as part of the software. And most people that are looking to adopt this, they really want to make sure that this part is really kind of like conducive for them and permissive for them to make the software more private. So for that matter, we perform this quarterly and actually just detect all the kind of like open source components that are used, just to make sure that we could mitigate for any possible supply chain risk. And our assessment is really twofold. The first part is really looks at the license assessment, which actually, ensures that everything we do, the licenses we utilize, are in lines with the module loop open source policy, which is Aperture 2.0. And this is really the most permissible we could get. We'll allow, everybody to use the software the way they want to use it freely. And for those that actually don't even mind to, make their software a little bit more public, you could link the Aperture 2.0 libraries into your kind of like GPL 3.0. But those are the nitty-gritties that people that are experiencing this field will have to, consult with the lawyers to make sure that that's actually feasible. And the second part of this assessment was really to look at, the vulnerabilities and the update of the libraries to make sure that they're not exposing our core, system. And for this is we really leverages, a couple of databases. However, we use a white source scanner to scan the entire code and do a lot of more work as manual analysis. So what we're going to see is really things that has been scanned with the white source tools get returned, and over 60% of it is just manual analysis. It's not something that you could click a button and have it at the back. And obviously, we do this within Cross Lake for other customers. We have a center of excellence that focuses on open source security. And we do over kind of like 300 of this for about 300 companies in the M&A space. And the contribution really is really high. In the past, it used to be considered kind of like maybe threat to penetration testing and static code analysis. But now in any mergers and acquisition is actually considered first to look at, if there's any risk that can, affect the ownership of the software and the security of the software as it will be running. So I'll just quickly give you a summary. There's a lot of details that we'll actually kind of like disclose to the team upon this presentation. And I will first share it with the DA and the core team, and just to desensitize it, and we'll share it publicly. I just put this one slide just to try and summarize everything, since Simeon gave me only 10 minutes. But here the key pointers really are, on the security side, we did a deep analysis of all the high security and the medium security finding we detected, and we couldn't find anything that actually has to do with a direct dependency. So all the libraries that we take and use them directly into the software, those actually do not have any vulnerabilities. But what we're seeing here, which is also a trend in the market, not per se, is most of this security finding that we have affects, transitive dependencies, which are dependencies within the packages we use or dependencies within dependencies. And for us, we've been discussing this, and Mila has been spotting a lot of events happening around the supply chain, risk. And we need to go back to the drawing board and look at our dependency strategy and see if it's fit enough for us to be able to sustain it and then help it to, to help us to mitigate as much as possible. Because if you see the number is about, 177 vulnerabilities. But when I dig deep on that number, we can actually go down to about, 20 to 25 odd libraries that we have to worry about. But, from a risk perspective, we have about, 5 libraries, which actually has a CVVS rating of above 9, which make it a critical vulnerability. So for these ones, I'm actually marking them down for prioritization so that the core team can have a look at this, because since they are kind of like have a high impact, we need to find a way of addressing them, even if they're transitive dependencies. And that's actually kind of like something that most people does. We just take anything that is critical and resolve it fast and then go down to anything else that as an order of priority. And on the license part, we're pretty kind of like been doing good, on a year-on-year. And I mean, last quarter, we actually recorded no GPL findings, but in this quarter, there's a couple of things that actually bubbles in that with GPL. But just to top level analysis, we actually had about 18 GPL libraries. And out of those kind of like 18 GPL libraries, 13 of them have alternative licenses that are kind of like permissive. And this really does not come automatically from the tool. The tool will tell you that, hey, I see this library that has a GPL license, and it's a manual exercise for me to figure out as to if the library has an alternative license, is that license allowed to actually be used standalone away from the GPL version? So in this case, we just actually have to be cautious so that it's not a dual license library where it requires both a GPL as well as an MIT or an Apache license. So we've actually done a validation of that. And then all these 14 GPL licenses have real alternative license that you could default to. And defaulting it is just changing, the notices, and we don't have to change the library itself. Then from then we should be good. And 5 libraries that have GPL only licenses makes us non-compliant with our own, license scheme. So obviously this has been marked, and the code bases that this libraries come from, I've marked them. And as you can see, some of them are not coming from the core code basis of Mojaloop, which is kind of like a first relief, but the fact that we're distributing it from our GitHub repositories may make us really liable to comply with the conditions of GPL, unfortunately. So the core team will have a look at this and how best we could actually avoid having them. And where we have them, we can actually declare them and change the notice and attributions to actually mention if there's anything that we have changed within those libraries. Then once those is done, and we should be fine in terms of the license risk. That's really kind of like in a nutshell. The next slide is really to do a comparison from where we started, in January this year. And as you can see, the code base is growing a little bit. The number of kind of like repositories is growing steadily, as well as the number of libraries that we have. So in this case, we scan everything. So even if there's noise in the first scan, there will be noise in the second scan. So the accuracy of this can actually be done by filtering a lot of, non-core repos, test repos, but, the consistency will still be more or less the same. But what is good here is that there's a high rate of libraries that are updated. And if you look at the number, it's actually well over 95% or about 94% of all the libraries across all the corners that we've been scanning. They're really updated, with only a few that we have to worry about and bring them to the latest versions for those. And also there's a use of kind of like multiple versions of libraries across code bases. And this is really very possible in cases wherein we have multiple teams that are contributing to this code. We have a team that actually did the testing toolkit is different from the team that has done the payment manager. So we're not going to be focusing much more to try and get the versions to the same, unless if those versions are vulnerable or wholly outdated, then we can actually resolve them across all the code bases impacted. And lastly, we actually took a snapshot of the white source benchmark database. This is a database of all the previous scans that customers has used white source to perform, and all what they do is they just averages what they see and set a ratio. So the ratio that we set there, which is an overall average, is pretty much how most people are doing. And above the line is really how Mojaloop is doing. So both on vulnerable libraries, we're doing better, and on outdated libraries, we're doing a whole lot better, wherein our average is much more lower than the standard average, which is actually pleasing. So this is really what we could share with anybody coming to adopt the software. And we've done all our works and the checks and balances. Our version management is working, and our vulnerability detection systems to a particular point are helping us to be as clean as we are. So that's really, really how we look at the moment. And in conclusion, we haven't done a lot this PI except for the first point, but also Louis as well and Sam has been continuing with the DevSecOps maintenance around vulnerability and patching. And they were looking to add a little bit more activity in the next PI around, code signing and also approving the standard and implementing a static code analysis tool, and as well as working with Steve and Paul to really kind of like align the messaging around the regulators and anybody else wanting to adopt this. So in response to some of the prospective adopters, we were being kind of like, helping, the teams and responding to tenders and making sure that we have an appropriate message out there that will actually help Mozilla to be well adopted. That's really what we wanted to share in a short space of time, Simeon. So I'll hand it over to you for any questions for myself and Pedro.
Awesome. Thank you so much, Godfrey. I'm unfortunately not going to allow too much time for questions. I see there's some chatter in the chat. So Godfrey and Pedro, if you guys, I see Pedro responding, but if you could respond, that would be awesome. Thank you so much, everybody.